In this video, we will study ejection system used in the injection molding machine. Ejection system is used to withdraw the molded product from the mold cavity. When the final component is completely cooled and solidified properly, it is to be withdrawn from the mold cavity. This removal of product is carried out with the help of ejector system. This system is in clamping unit of the injection molding machine we have already studied earlier. There are different types of ejectors used as per different applications, but ejector pins are generally called as knockout pins. Those are most popular type of ejectors. In this system, the ejector pins are connected to ejector plate. The ejector plate is connected to ejector bar, which is operated hydraulically during ejection process. Here in this animation, we can see the ejector bar operated by hydraulic system. This is ejector bar which is operated by hydraulic system. Then this is our ejector plate and these are our ejectors. The red color part is our product, which comes in contact with the ejector pins during ejection process. Now we have seen this. These are ejector pins, generally round in shape or cylindrical in shape. These pins are properly treated to be hard, stiff and durable during ejection. They should not bend during operation due to excessive stress or excessive temperatures. So we have already seen this animation where the injection material is in red color and this is withdrawn with the help of the ejector bars moving in the forward direction. Part is ejected. Now we will see different types of ejectors during next few slides. So first one is pin ejection system. Uses pins for ejection of the product from the mold cavity. The pin ejectors are positioned where release resistance is higher. These are evenly positioned over surface of component for uniform resistance. The use of number of pins depends upon size of the component. Here you can see the animation explains the process of pin ejection. So these are our pins and this is our product. So with the help of ejection pins, the product is withdrawn. Next is boss ejection. The boss ejection is used when there is a boss or rib in the component. We have already studied what is a boss and ribs and when to use these boss and ribs in chapter number 4, that is design of plastic parts. Stepped pin ejection system shown in the figure is used for small and delicate components. Here you can see this small component. To remove these delicate and small parts, staple type ejection system is used. Next is disc pin ejection system. The disc pin ejection system is used for ejecting discs or cups. It has wide contact with the component as we can see in this animation. So it makes large contact with the component by making easily withdrawing. Next is sleeve ejection. The sleeve ejections are used to withdraw delicate, precise components and good appearance. A sleeve is used to remove the component. The striper plate ejection has an advantage of wide area for contact during ejection of component as compared with others. The ejection process is reliable even if the resistance is high. The appearance of the removed product is better as there are no traces on the component because of contact between striper plate and the component. The compressed air ejection uses compressed air to remove the product from the cavity. This system uses deep containers, generally round in shape, to support the ejection of parts and to eject part smoothly. Unlike pin ejection, this method making removal of components by even pressure and does not cause any defects like cracking, deformation, etc. So you can see that here compressed air is taken in and this lifts the component in the upward direction by withdrawing the component from the mold cavity. Here also we can see the ejection system using compressed air like this. Air is coming from this inlet and the product is removed in this direction like we can see here. Next is hydraulic ejection system. The hydraulic ejection uses hydraulic devices to eject the parts. This system is very flexible as the variation can be made by making changes in the setting. The system is also easy to control the process as hydraulic systems are very easy to handle and control. As we know that the cooling and temperature control of the mold affect product quality. So to maintain proper temperature of mold, the temperature controlling units for the molds are important. Generally, the mold temperature control system affect cycle time and product quality as the most of the time are used for controlling the temperature and cooling of the mold. Around two-thirds of the process time is used for only cooling. So cooling and temperature control of the molds are very important aspects from mold design. The temperature control system consists of many sensors and controllers which are required to operate cooling supply lines. The cooling supply lines are drilled or machined in the mold plates itself. The temperature controlling units or controllers are used to control temperature of the molds. The temperature control units are used to preheat the mold and then to keep at the set point temperature of the mold by circulating coolants like water or oil through the mold channels. The coolant absorbs heat from the mold which has absorbed heat from the hot plastic material and keeps the mold at proper temperature to solidify the plastic. Whatever change in the temperature of the mold is sensed by different sensors used in the mold. As you can see here, this is our part, and there are sensors used to sense the temperature change in the mold. Whatever the change in temperature is there, those are sensed by the sensors, and sensors send feedback to the controllers. And to maintain the temperature of the mold at set point, the controller activates the supply line here. Those supply lines are providing coolants to the injection mold by setting the required temperature at the desired point. In this way, the temperature control system works for injection molds.